In the last video, I showed you how to do an exploratory factor analysis. In this one, I'll show you, hopefully briefly, how to do an confirmatory factor analysis in Mplus. As I am new to Mplus, I do not know all the ins and outs yet and how to manipulate everything, but I do know how to run it and how to interpret it. So let's start with that, and if I learn more about it, I will make a more complex video later that shows you all the details and all the little things you can change. Okay, over in Mplus, what I want to do is copy my EFA input. If you haven't gotten to this point, you can go back through the videos as we started from the beginning all the way up to this point, and then you'll have these files to work with. So I'm just going to copy this input file and create a new one and paste that in here, and instead of EFA, we're going to call it CFA. And the file is still the same, and so the variable names are the same. And I do want to use the exact same variables as my EFA, unless of course I dropped a couple. In fact, let's do that. Let's drop a couple. Notice, or remember from the EFA, play, was it 4 and 6 didn't play well together. So I'm going to drop play 4, and I'm going to drop play 6 in the variables I use. And that will impact the way we type out our syntax in a moment. Now, instead of analysis type, we're going to change this up. It's going to be a model. Model, colon, and let's tab that in. And the way you specify a CFA is you have to give a new variable name for the latent unobserved variable, and then say it is measured by a certain number of measured or observed variables. So, for example, our first set is play, right? So let's call this play by play 1. In fact, I'm just going to copy that line up there so I don't make any mistakes. Copy, and I'll use it down here. Just paste that in there. And importantly, after you do that one line, you need to semicolon it. Hit enter. Let's do it again. We have next is info acquisition, so I'm going to call this info is our new variable. Oops, let me lowercase all that. Info by, I should probably caps this. It's again not required to use caps, but it does make it easier to read. Now, if you have a set of variables that are all in sequence, like I do for information acquisition, I could just say info1 dash info 5. And what that does is it says, oh, I'm looking for info 1, 2, 3, 4, and 5. I couldn't do that with play because I got rid of 4 and 6, so I had to specify. Now, I could have said play 1 dash 3, like that. Play 1 to play 3, and then space 5 and space 7. That would work like that. Can I control Z? I can, cool. But I'll just leave it like that. And then semicolon that. Let's do the next one. This is decision quality, so DEC, I'm going to say Q at the end of that, by, and I'm just going to do DEC Q1 dash DEC Q788. Semicolon, last one, use by use 1 dash use 7. All right. The last thing we'll want to do here is specify that we want standardized output. The default is to give you unstandardized loadings, so those might range above 1, but I'd rather see on the model the standardized loadings. So we'll say output colon std for standardized by y and x. There's also a std just y, or just an std, which sounds terrible. It's abbreviated for standardized, but unless you're using discrete variables, unless you're using like categorical variables, excuse me, you'll just use the yx. If you're using categorical variables, then use just stdy without the x. Okay, let's save this. We'll call it Mplus Mplus CFA, and we'll run it. Hope it runs. Yay, it ran. And here's all the output. Now it's going to look a lot like your EFA. So what I'd really rather do, well, let's look at the model fit real quick. We need to look at the model fit. Unlike the EFA, in this case there's just one model. We aren't testing multiple models because it's not exploratory, it is confirmatory. And so the model fit is just for this one model here. And the RMSEA should be less than 0.06. In this case it is not, unfortunately. The CFI and TLI should be above 0.9, which they are. If you're going to be strict, it's 0.95. SRMR less than 0.08 looks great. Okay, and then you can see the model results here. Notice these are not standardized estimates listed here, but we can get the standardized estimates in the diagram, which we're going to print out in just a sec. Okay, so there's all that information. Let's go ahead and just look at the diagram, or here are the standardized effects if you want to see those also in a table. So let's go to the diagram right here, view diagram, and it'll show you the unstandardized first. Let's go ahead and go up here to view, and let's say, whoops, view, I want to see the STDYX, and now we see the standardized loadings. Again, in the parentheses, these are standard errors, not p-values. Okay, you can also see the correlations over here, and their standard errors. You can also move this around as you please, or you can even zoom out. There's a zoom out button here, and we can zoom out as far as we need. And if you wanted, you could also save all this to a PDF for copying later. Let's see, export to PDF. You can export this whole model to a PDF file, which you can then copy as a picture to your report or wherever you want. Anyway, that's the CFA. Standard rules apply. You want to see loadings averaging out above 0.7. That doesn't mean every loading, standardized loading, needs to be above 0.7. It just means they need to average out above 0.7. You want all the loadings to be significant, and you want these correlation values to be less than 0.8 definitely, well, less than 0.9 definitely, less than 0.8 ideally, and have them be, to establish discriminant validity, you'd want them to be as a different, further away from each other than the AVEs. So you want the average loading over here on your factor to be greater than the square of the correlation over here, which in this case it is in all cases, because the square of that's going to be about 0.51, and these average out clearly above 0.51. Anyway, that's how you do it, a basic CFA. Maybe I'll make another video later on how to do all the validity testing and all that. Hope that helps.